start talking about the formula for permutations. Because what we were doing on the front side with the candy bars, that was technically permutations as well. But there is a specific formula we can use for situations where we're not using all of the numbers that we have. So for the candy bar example, he was eating all 5 of the candy bars that were in our pool. This is going to be this formula can be used for that situation, but also is useful for situations where you're not using all of the people that you're pulling from the pool or all of the things. So the formula is represented by an NPR, with our N being a variable and an R being a variable. All the P stands for is permutations, so it's just telling you that you're working with permutations. And the reason we talked about factorials and fractions is because the formula for this is N factorial over N minus R factorial, where N, it should be a bigger number in the top, or identical to what's in the denominator. So for N factorial, for N is the total number of items. So total number of items. It's kind of like a T. Total number of items. So when we're talking about a candy bar example, our N was 5 because we had a total of 5 candy bars we were choosing from. Our R is the number of items taken. I'll move that way here in just a second. R is the number of items taken. So in our candy bar example, these were actually the same number. They were both 5 because we had 5 candy bars to choose from, and we were taking 5 of those candy bars. So that's a situation where we actually don't need this formula because the bottom, for that, if they're both the same number, the bottom doesn't matter because it comes out to be 0 factorial. We don't have to worry about it. But for a situation like this example here, where it says John is the coach of a 13-player baseball team, although there are 13 players, the batting order consists of only 9 players. How many different batting orders can John create? This is a situation where we have 13 players that are our total number of items, but we can only take 9 of those 13. We can only take 9 of those 13. So this is where this formula becomes important because we're not taking out all of those items. So I want to get this done before lunch, so we're going to fly through this piece. So identifying the pieces that we need to identify what our N is. And for this, N is the total number of items, so our total number that we're choosing from is 13. We need to know how many items we're taking out of this 13. That's going to be our R. So what is our R for this? 9. It is 9. So we have to choose 9 people from the 13 that we have on the team. And so it says, how many different batting orders can John create? So we're going to use this NPR formula that's up here. So NPR. So again, the P is not a variable. It just stands for permutations. When we talk about combinations on Thursday, it's NCR instead to tell you that you're using combinations. So our N here is 13, so I'm going to go and replace N with a 13. So it's 13P, and then our R is 9, so I'm going to replace the R with 9. So it's 13P9. And I'm showing you this format for it because some of the problems on today's assignment actually use the 13P9 or whatever numbers go there. All right, so if we actually solve this out, replacing all of our N's with 13, so it's going to be 13 factorial over, down below we have in parentheses 13 minus 9 factorial. We go ahead and do that subtraction. So 13 factorial is still going to be in the numerator. If we do 13 minus 9 factorial, it's going to end up being 4 factorial in the denominator. That's from the 13 minus 9. Now we can do some canceling out here. So we have this 4 factorial in the denominator, which means we also want to cancel out that 4 factorial. So I'm going to write a 4 factorial up there. But we need to start counting from 13. So here's an example where you normally use a calculator. I'm going to write it out though. So you have 13 times 12 times 11 times 10 times 9 times 8. I'm going to run out of space. 7, 6, 5. So I kind of crammed that in there. But it is counting down from 13 down to that 4 factorial. So there is a little 5, I promise. So our 4 factorials are going to cancel. This will leave behind 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. Yeah, that's a lot of numbers. And that's why I am going to show you guys how to do this on the calculator. Because when you have problems like this, I don't want you to necessarily be writing this out a whole bunch. But I do want to show you it. So, in this case, I'm just going to type this one in the calculator. If you type it into the calculator, so when you multiply it out, you actually did it right. It comes out to be 259,459,200 batting orders. So yes, it is a giant number. So John has a lot of different options to choose from. A lot of different ways he can organize his players for their batting order. Any questions about that one? So on the calculator, I'll show you on this next one. The next one's one I'm going to show how you actually do on the calculator. How much time do we have before lunch? We have 6 minutes. We need to get this done. Because this is the last thing we're going to talk about today. Any questions specifically on the baseball example?
So they're all pretty much the same?
They are, for the most part, they're similar or the same as that. Okay, so this next example, it says 20 people are running a race. The first 3 places are awarded gold, silver, and bronze medals. How many different permutations of medals can be awarded? So looking at this, what is our N going to be? How many? What's the group that we're choosing from?
20.
It's 20. There are 20 people running in it, so that's our total number of items. It tells us that there are 3 places that are being awarded medals. So what is our R? It is 3, because there are only 2, or sorry, not only 2. Only 3 people can actually be chosen out of this group. So there are 20 people running, but there's only 3 spots that we can fill. So we want to figure out how many different permutations of medals there can be. How many different ways could the people be placed and get with being a gold, a silver, or a bronze. So keep in mind that order does matter here because it's very different if somebody gets a gold than if somebody gets a bronze. So something I want to stress is that permutations are always when order does matter. So we are using NPR. Where N is 20 and our R is 3. So if we plug this into the calculator, or if we plug this into the fraction, 20 factorial over 20 minus 3 factorial, which is going to end up being 20 over 17 factorial. Now, this one we actually wouldn't be too bad to do by hand to expand out, but I'm going to show you in the calculator how to find the factorial button. So you're looking at a calculator. It's not on the front of the calculator because if you look through these buttons, there's no factorial symbol. So to get the factorial symbol, I'm going to type out 20. You have to hit the math button. So it's the third button from the top left. When you hit math, it's going to bring up this a set of menus that say math, num, CPX, or PRB. We're going to go over to that PRB one. And you'll notice some things that are somewhat familiar in there. The fourth one down is our factorial. So if you type factorial, so 20 factorial, and we take that 17, divide it by the 17 factorial, hit enter, That's going to give us our permutations. So that can save some time on certain ones. So this would be 6,840 permutations. All right. Any questions about this one where we found 6,840 permutations? Everybody feel okay about that?
Oh, hell no. What about the bottom?
We're not going to talk about those today. We are going to talk about we'll talk about those on Thursday. Okay, so one last thing I'm going to show you. There's actually even an easier way to do these. I'm going to show you this because some people probably figure it out. You could actually use another function that's in the PRB. Hopefully you're paying attention. There is an NPR and an NCR in here. So that NPR function, if you hit enter and if you take the 20p3 and plug it in as 20 NPR3, it's going to give you the same answer. So that's also something you have available. It isn't